Willman Education. Welcome dear learners. Today's topic, rectilinear propagation of light. Here we will see how the light travels in a straight line. Light travels in a straight line as long as it travels in the same medium. Here is a light ray from a source. You can see light travels in the straight lines, and this property is called the rectilinear propagation of light. If an opaque object is placed before the ray of light, what will happen? We will come to know. First, we will see the experiment how the light travels in a straight line. That we will see first. Here is the experiment to show that the light travels in a straight line. Materials required: a candle and 3 rectangular cardboard of the same size. Procedure: make a hole at the center of each cardboard. Fix the cardboards on a wooden base so that they remain upright. Arrange the 3 cardboards one behind the other such that the holes are in the same horizontal line. Place a burning candle or a torch behind cardboard or C. Make sure that the candle flame is at the same level at the holes of the cardboard. Then now look at the holes of the cardboard. A. You can see clearly the candle flame through the hole. Now displace cardboard B. Look the here, if you displace, then look through the hole B in a cardboard, you won't be able to see. So this is the thing what I have drawn to show you the experiments. That means one cardboard is little displaced from the straight line, then you won't be able to see the ray of the light. Here is the application of rectilinear propagation of light. The property of rectilinear propagation of light has many applications in our daily life. Shadows form because of rectilinear propagation of light. Day and night occurs because of the fact that the light travels only in straight lines. Eclipse occurs due to the rectilinear propagation of light. Number 4. A pinhole camera works on the principle of rectilinear propagation of light. Now we will talk about the pinhole camera. A pinhole camera is a simple device used to take photographs of stationary objects. It works on the principle that light travels in a straight line. The working of a pinhole camera. Place a lighted candle AB in front of the pinhole H of the camera. Rays from the flame will travel in all directions. A ray starting from A travels along AH, passes through the pinhole H, and falls on the greased paper screen at point A1. Similarly, another ray starting from B travels along BH, passes through the pinhole H, and falls on the screen at the point B1. Thus, all the rays starting between points A and B of the candle will pass through the pinhole H. This is the way you will see the shadow. Now the shadow formation. You can see there is a shadow formation is shown over here. So remember that in the pinhole camera, the size of the image and the nature of image is also very important. So conditions for the formation of shadow. Conditions, that is, first of all, source of light. Number 2, an opaque material blocking the path of light, that is the straight line. And number 3, opaque screen for obtaining the shadow. So characteristics of a shadow. A shadow is always a dark area. Text, it does not show the color of the object. Very interesting. The second characteristic is this, that a shadow may or may not look like the actual shape of the object. These are all very common experience. if you do it, this experiment or this activity, you will be able to see these characteristics are all visible and evident. Number 3, the size of a shadow depends on the distance of object from the source of light and screen. That's another important characteristics of a shadow formation. And we are of rectilinear propagation of light. Number 4, a shadow can only be formed on a screen. Shadow can only be formed on a screen. So this is also another important characteristics of shadow formation. So this activity you can do on your own at home. You can practice it. There is no doubt that you cannot do. You can do it. Here is a torch light, and this experiment we are showing here that shadow has two parts. One is a central dark region called umbra, and the outer less dark region called penumbra. So that is shown over here with the neat diagram. The umbra region is a total darkness, as no ray of light enters this region. Remember it. The penumbra receives a few light rays so that it is less dark. The formation of umbra and penumbra depends upon the size of the light source and the distance between the object and the screen. That is very important. So practice this diagram, because this is very important diagram to understand the thing. So now when the ray comes from the point source, so first of all, shadow from a point source, this is the diagram. Here you can see that the light comes from a point source. Certain characteristics we observe over here. Characteristics of a shadow formed by a point source of light: uniformly dark, sharp at the edge, and bigger than the size of the object. So these are the characteristics, and that you can see only when the shadow is formed by a point source of light. That you have to keep in mind. Now, shadow formed by an extended source of light. The shadow formed due to an extended source of light smaller than the object. If the object is smaller, then what will happen? And if the object is larger than the light source, then what will happen? So here it is shown over here. Then we are going to the shadow formed when the source of light is larger than the object. So here is the diagram. You can see when an object smaller than an extended source of light is placed in its path, and the shadow formed consists of umbra and penumbra. The umbra in this case is very small, as shown in the position. So here the umbra is not only smaller than the object, but also smaller than the penumbra. If the screen is moved away from the object to position, then we are coming to the eclipse. Following this principles of propagation of light in the rectilinear way, so we come across the very common examples of our life, day-to-day life, that is solar eclipse and lunar eclipse. A total solar eclipse and partial solar eclipse. Remember that solar eclipse, what is called solar eclipse, and there are two types of solar eclipse. This is the partial solar eclipse. First one is total solar eclipse and this is the partial solar eclipse. So total and partial solar eclipse is shown over here with the diagram. Actually the region is very important, from which region people are viewing or watching, that is very important. So in that way it will be solar eclipse. So in the earth all the people will not see the solar or the partial solar eclipse, total solar eclipse or partial solar eclipse. No, all depends on the location. Now lunar eclipse. Here is the lunar eclipse. When the earth comes between the sun and the moon, the shadow of the earth falls on the moon and the moon becomes invisible for some time. This is called a lunar eclipse. So when the moon lies completely in the umbra of the earth's shadow, it does not receive any light from the sun and so does not reflect any light. So the moon is not visible to us at all. In this case, a total lunar eclipse takes place. When the moon lies in the penumbra region of the earth's shadow, it receives some light from the sun. This light is reflected by the moon and reaches us on the earth. So the penumbra region, the moon is visible, but it is less bright than normal. As the moon begins to enter the umbra, the part of the moon inside the umbra becomes invisible. So we can see only the part of the moon which is in the penumbra. This is called partial lunar eclipse. So please subscribe this channel as fast as possible to get more informations and lessons. Do support this channel because this is a free channel. Please share it. Thank you.